Okie dokie. Rectangular hyperbola. Now the book talks about y equals a divided by x as this family of hyperbola where a is just some constant number. Alright, we've been looking at linear equations, like the most simple y equals x. This equation doesn't look that different, doesn't look that complicated, but you can see the shape of the graph on a Cartesian plane is quite different. Just before I show a table of values, we've got y equals 1 on x. We could have multiply both sides by x. We could have xy equals 1, same thing. We could divide both sides by y. Just do that quickly. There we go. X equals 1 on y. Can you see it's all the same equation? I'm just rearranging it. But normally written y equals 1 on x. Now if I go to a table, if you're unsure why it takes on this peculiar rectangular hyperbola shape, go back to, I don't know, what do you call it? First principles of graphing, and think of a table of values. All right, so we've got our x's, nice whole numbers, then we've got our y values here, and they're coming from 1 divide x. So I might add a few more down here. What's happening? So if x equals 1, we'd have 1 divide 1 is 1. Right, that would be here. Okay. If x equals 2, we have 1 divide 2 is a half. You can see how the numbers are going to get smaller and smaller. So if x is 3, we've got a third. If x is 4, 1 on 4, a quarter. X is 5, a fifth, and so on. So that's why this is curving downward here. And by the way, I'm ignoring negative x's at the moment. We're just looking at the quadrant 1. Why is it that when the x is between 0 and 1 in this space, this curve just shoots upwards, right? And if I zoom out, you'll see that it's still going, it's shooting upwards there, right? So if I can put in some extra points, if we had x is a half, the y value is 2, that's just popped up there. Does that make sense to you? So you'd have 1 divided by a half. It's the same as saying, how many halves are there in 1? There's 2 of them, right? If I change that to maybe 1/10, and it won't fit on there it is, it's up here. So I'm saying how many tenths are there in 1? Because I've got 1 divided by 1/10. There's 10. You can imagine if I take this out to very small numbers, how many hundredths? 100, 1,000, 1,000. You can see that, what have I gone up to 10 million there? You can see that this number is just going to go up really high. Now, if I zoom in, maybe take it up to a y value of 100. If I zoom in, it's getting very, very, very close to the y-axis, but it's not touching it, right? And it will never touch the y-axis. So let me just make that 1/10, I think. So hopefully you've heard this word before, but we have an asymptote. Might even draw it on at x equals 0, and it's the y-axis, right? Don't need to draw it on, it's right on the axis. We also have a horizontal asymptote. You can probably understand that one from the rearrangement. If we had x equals 1 on y, right? And we look at that y value there, it can never equal 0, right? Same as when we've got y equals 1 on x, which is the blue. That x can never equal 0. We cannot divide by 0. Rectangular hyperbola show really nicely why you can't divide by 0 in mathematics. As these x values get smaller and smaller and smaller, if we divide by really small numbers, we get big numbers. However, if we then make that negative, so maybe looking down here, maybe I can go on my table, put one in. So if I had minus 1/10, there we are. Right, the y value is now minus 10. You can see that already, or the shape. So this line is going down to minus infinity in its range. And you know, what happens at 0? Well, nothing. The x can't be 0, and you can kind of see why. That there's this discontinuity, right? That function will keep going that way. Something happens at 0. Well, it's undefined, because then just on the other side of 0, the function's jumped up from very negative values to very positive values. So in between all that, right on the x equals 0, or the y-axis, we have an asymptote, and might be able to see this a bit more clearly. If I was to change that position, let's do a -2, it'll shift it 2 over to the right. What we've done there is we've introduced a new horizontal asymptote at x equals 2. X can never equal 2, because you'd have in this function 2 minus 2 is 0 now, right? So the whole thing's shifted over. In fact, if I was to draw or attempt to sketch this hyperbola by hand, I would draw in this line first, and then I would draw my hyperbola. So I would actually put in the asymptotes. You can have another one. I could take the y equals x. Let's just look at it again quickly. This is your most simple. The one that you kind of have locked away in your memory after a while is, this is the shape of a hyperbola about the x and the y axis. If we are to do a few little modifications, maybe I'll add 3, right? It's as if I just lifted the hyperbola up 3 units and shifted it over twice, 2 units. Before I did a sketch of that, I would actually draw in those asymptotes. So we had y equals 3. And then I would sketch in my hyperbola, not worrying about it too much, because it's just a sketch, right? I wouldn't have to plot 10 different points. So you draw in those asymptotes. It makes sense. I've explained why you get this vertical asymptote at 2, because that's where you're going to get your new 1 divides 0. You can't do that. X can't be 2. Does it make sense why you've now got a horizontal asymptote at 3? Basically, you think of your normal y equals 1 on x hyperbola. You've taken that and you've lifted it up 3 spots. So you see that 3 and you go, okay, that's where the x-axis used to be. I've shifted it up. You've got a reference point, right? So you draw those, then you do your sketch of your function. Okay. Now, just doing a brief intro, so I don't want to labour on these too much, because we can discuss more later. If I was to make everything negative, what's going to happen is all of these y values here that are positive are going to become negative. All of these negative values here, I'm going to have negative of negative, they're going to become positive. So if I whack on a minus here, right, so we used to have values there, they're now negative, they're down here. We used to have values here, they're now negative, negative of negative, up there, they're now positive. Right? So hopefully that's not too surprising. All right, the book straight away says y equals a on x. So let's use a little a. Okay, what's going to happen if we increase the value of that A? All right, so you can see this dilation happening here. I'll bring it all the way out to 10. Right. Now, in terms of the shape, it's actually not doing that much, especially if you zoom out. It still looks like a rectangular hyperbola. But you can see the values are, the y values are going up a bit there, as you'd expect, because we're multiplied by 10 on top of the function. That's about all there is to say about this. So the shape kind of holds, sort of changes a bit. If you were to go negative in your A, then it's going to do what we showed before. All right, so it's going to swap quadrants, and we've already looked at that. So there isn't really too much more to say. In your textbook, they're going to start questions looking at the hyperbola in this form. So let's quickly discuss that. When we've got xy equals a, the idea is that a is some constant value. And one of the questions that I'll do in the next video, I'll see if I can get a pen to show up so I can type. Write. No, that's not working. Anyway, in the next video, the first question I will do, there it is. Yeah. Actually, we can find it. Well, maybe I'll do those first, but this one here, speed. And speed is basically, let's write out the formula. For speed, it's a distance, a d for distance, divided by a t for time, right? In this particular question, the cyclist's going to a friend's house. Well, that's a set distance, right? So you could rewrite it as speed times time equals distance, but we make that a constant amount. In this particular question, it's 96. So it doesn't change. And it takes on the form, even though it's speed times time, it's taking on this form xy equals some number, right? Okay, we'll end it there. And then in the next video, we'll do a few questions.